Uh, okay. Well, let me just do that on Discord. And boom. Nice. Let's just grab this. And that's good. All right, let's just get right to it. Okay, why? Cool. Let me just reload this then. Nice. Let's continue.
It is going to be very common from one script to have to do something with another game object of the scene. We are going to see some possibilities. Communication between objects. There are many ways we can use to communicate between objects. One possibility, and we are going to see an example, is in an explicit way, with a public attribute of the type GameObject or transform in the script, over which we will drag and drop an object of the scene in the editor. We can also use transform.find, GameObject name, that will look for the object it is in the parent-child hierarchy of the transform object.
With a public attribute of the type GameObject. Okay.
We can access to all the children of a specific game object.
I've forgotten a lot
of things. For each transform child in transform. Or we can use GameObject.find and the name of a game object that will look for objects with this name, active in the scene. We can also look using tags, using, for example, GameObject find with tag. Once we have the reference of the object, an object we want to do something with it, we can get access to its components, even the scripts, using getComponent. When looking for objects, try to do it that in the start or the awake. So you get the reference of the object and you store this reference in an attribute. And you will use this attribute afterwards in the update and the fix update. We can also communicate among objects using the methods sendMessage, broadcastMessage. With sendMessage, we can execute a specific method of any script that belongs to the particular object. With broadcastMessage, we can also execute a method of any script that belongs to a particular game object, and also with all the children this game object can have. Here you have an example. So imagine that this script belongs to a specific game object, and we want to execute a method of another game object. So in receiver, we have to do whatever we need in order to get the reference of the other object. Once we have the reference of the other object, we can use receiver.sendMessage, in this example, die. So we will try to execute the method die that belongs to a script of this object, the receiver. Okay, so method die that belongs.
Public class sending message. Okay, so receiver is not defined. Or, yeah, it's not defined. Because it's an object. Okay.
Belongs to a script
Sure.
of this
I'll
object.
just, that's fine.
Okay, so communication between objects is going to be very useful in Unity. We have learned different possibilities of communication, but we are going to see them better with a little example.
Cool.
It is going to be very useful to communicate between objects, to be able to, from an object, to send a message or to do something with another object. This is something we do quite often in Unity. We are going to see in this video an example. If you remember, when this example was kinematics, we were able to solve a very interesting problem. We were able to make the camera to follow the sphere. How we did that? It was very simple. We just had to select the main camera and to drag and drop the main camera over the sphere. So making the main camera as a child of the sphere. This solution worked very well when the
Okay,
example was
yeah.
kinematic. But what happens now? Let's see. If we run, you're going to see that there's now a very important difference. Now that the example is physics, when we push the sphere is rolling over the surface, over the plane.
Oh, that's...
And by rotating, of course, the camera, the child is going also to rotate.
Okay,
So we cannot
that's
use the solution for this
interesting.
specific example. We have to do something different. And what we are going to do is to solve this by creating a specific script. So if you see
That's
right now, we
interesting,
have here the camera,
for sure.
and the camera is at a certain distance from the sphere. So what we are going to try is to create a script for the camera. And this script is going to follow the position of the sphere. But we are going to keep this initial displacement we have right now. So right now there's a vector that is separating the camera and the sphere. We are going to try to keep this distance. And in this script, we are going to update the position of the camera accordingly to the new position of the sphere. We are going to do that by creating a C# script we are going to call follow.
Sure. I actually don't need this other window open. But sure, let's get it. Let's call it camera follow. Okay, also I already forgot. Like there's kinematics and then there's something else. I already forgot. Great.
This man did
Oh
it! This
my,
man
bruh.
actually did it!
Okay, thank you, XAE69, for the follow. I greatly appreciate it. Every little bit helps towards making my dream come true and proving my family wrong, so thank you. So I'm genuinely grateful. I haven't said that in kind of a long time, so thank you for the follow. Okay, so let me just do what he wants me to do here.
Okay, so what are we going to do in this follow script? Okay, we are going to communicate, as we are going to see, between game objects. This script is going to be a script of the camera, but as we are going to see, I'm going to be able to get access to the game object of the sphere. How can I do that? Well, one way to solve this problem is by making something like this, creating a public game object we can call, for example, target. By making this game object public,
Okay.
we will be able to modify it in the editor. As a matter of fact, it's going to be convenient to initialize it in the editor. And we are going to initialize this target object in the editor with the sphere. So when we do this, you are going to see that in the start and in the update, if I consult target, I'm going to be consulting the sphere, our main character. So this is the very first thing we are going to do. Now we are going to do something also necessary because we want to keep the distance between the sphere and the camera. And this distance is going to be a vector 3. We are going to call, for example, offset. So we are going to calculate this vector, this displacement we have from the camera to the sphere. And we are going to calculate this distance, this initial distance, by using something very simple. We are going to initialize in the start. So we are going to take this distance when we run our scene. And this is going to be something like transform.position. So transform.position is the position of the camera right now. And we are going to subtract to this amount target, that it is going to be the sphere, the transform position. So again, you have to pay attention that in the case of C#, we have also some operators overloaded, and the minus is one of them. When we are subtracting, in this case, transform position with target transfer position, we are subtracting two vector 3s. So this is going to create a new vector with the subtraction for each axis, x, y, and z, okay? So the result of this is going to be a new vector with the distance as a vector between the sphere and the camera, okay? So instead of using
okay, I guess I kind of get it a little bit. Maybe. Okay, I don't know what I'm doing. It's supposed to be right here, yes. Public Game object. He did target? I don't know why. Braggart? Private. Vector 3. What is this? Representation of 2D vectors and points. Okay, vector 3. Vector 3. Representation of 3D vectors and points. Okay. I'm guessing it's like the sum of all, it's like the sum of all the vectors of a 3D object, something like that. I'll figure it out. This is not the first course I'm going to take, so. Offset equals transform dot position minus target dot transform dot position. Wow, I'm really like, I'm really not in the mood to absorb information right now, but I have to do this anyway. Because the course is going away in like 5 days, so. Very cool. Okay, so what does this do? This offset target I'm a little confused about this. I'm assuming the ball is going to be the target, right? Because the target and the offset can't apply to the same object, so. Alright, I guess we'll watch.
The
I'll
update,
watch.
I'm going to use the late update in this case. So remember, this script is going to be in the camera. So what is going to happen is, in every frame, the sphere is going to change its position in the update, remember, okay? So in the same frame, the camera is going to update its position in the late update. So remember that first the updates are executed in every frame and then the late updates. So in this way, I'm going to be sure that when we update the position of the camera is after the sphere has updated its position in its update. Okay, so normally these kind of things, these dependencies between one object and the other, is solved in the same frame using update and late update. So in this case, we are going to do something very simple. We are going to modify my position, transform position, and my position is going to be the position of the target. In this case, remember, this is going to be the sphere. And of course, I'm going to increase offset. The distance we have, the initial distance we have between the camera and the sphere. In the case we don't add this offset, we are going to be in front of a first-person game, okay? So the camera is going to be inside the sphere. With using this plus offset, we are creating what we call a third-person game. So the camera is going to follow the character.
Wow.
Okay, so this is the script we have created. And you have to remember that it is going to be compulsory to initialize this target, okay? Very important. And this is what we are going to do.
Okay, sure. Initialize the target. Offset equals transform dot position minus target. So it's like, okay, it's so it's taking the distance between them, right? Okay, wait, so transform dot position. Yeah, okay, so it's taking the distance between them and then it's adding it back. I feel like there's an easier way to do this, right? I don't know. Maybe not, but whatever. And I like how he removed this comment just to like, I don't know, just because of OCD or something. Okay, transform dot position equals target dot transform dot position plus offset. I will just trust him on this.
Important. And this is what we are going to do. So now in Unity, okay, what we are going to do is to drag and drop the follow script, okay, into the camera, okay? So remember, I'm going to put the camera out of the sphere, so the camera is going to be in a principal
Yes,
object, okay?
makes sense.
It's not going to be the child of the sphere. And now I'm going to drag and drop the follow script into the main camera. So we select the main camera, and remember, this is very important, we have to
Oh, that makes sense. That makes sense.
have the follow script, okay? So in target, as you can see, we have none. This means that we have to initialize it. If we don't initialize this target, when we run the start and the late update, we are going to have an error, okay, in execution. So we have to initialize it, and we have to initialize it with the sphere. So we have just to drag and drop the sphere here, okay?
Okay, so if I could just do this, right? I could just select it. Or I could drag it. Got it. But dragging is kind of easier because sphere is at the bottom. Okay. I don't... I don't really know why I... Okay, actually, I can just do this up here. Got it. Fair enough. And this? Why did I do that? Okay, whatever. Cool, so sphere. Okay. So I just don't have to click on it first. Hoggers.
So this is the idea. So in this way,
It's the
when we
idea.
run now,
Every time I get on here, you are just messing with... Stop.
the target is going to take the reference of the sphere. So the script is going to have as target the sphere. So when we consult the transform and the position, we are going to be consulting the position of the sphere. Okay. So let's try to see if it works. So now, as you can see, we can.
Yeah, let's try to see if it works. Let's try. Let's try to see if it works. Let's not see if it works. Let's just try. Okay, so the real question is, am I going to be falling forever? Yes. Okay, gravity? Can I change gravity? No? I guess I can't do it right here. So great. Bang, 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 bang. Okay, great. I don't know why I don't exactly know why I made these. And just turn them off, I guess. Okay. So wait, it has to be convex. If I shut that up, got it. All right, I do have to remember that. I have to remember that. So let's get it.
Move the sphere, we can even jump, and the camera is following the sphere. Okay, and of course the sphere is now rolling over the surface of the plane, but this is not now a problem, okay? So this is a very good example on how, from inside a script, we can get access to another game object.
Wow. Very crazy, thank you. Thank you very much. 16.18. Let me think. I was gonna do something, I feel. I feel like I was gonna do something. Oh yeah. Types. Let me do 2 types of movement in Unity. Movement in Unity. Okay. Oh. You know what? Let me just see. Huh. Dynamic. What is it called, bro? What is it called? I think it was like in one of these slideshows. Hello. Welcome. Okay. Introduction to Physics. It might have been here, and I was just there, but whatever. Empty. Game object. Transformations. Transform. Geometry, mesh render. Okay. What is this again? Let me look. Mesh renderer sphere. Oh, collider. Got a collider is the hitbox. But yeah, welcome to the stream. I said hello, but that might not have been clear enough for you to realize I was talking to you guys. Hello, welcome, first time here, welcome. I kind of like how they added that. Okay, can I please physics in Unity? Are not going to be under the control forces. They are used for special cases. Okay. Bruh, I seriously don't know. What is the other kind? I'm sure it doesn't matter right this second, but it's just bothering me. Unity in action. Yeah, I'm almost done. This is seriously like mega intro. Like he doesn't really tell you how to make an actual game. This is seriously just like mega intro. I don't know exactly how this is like a course, like an actual course, because like this is supposedly a college course. I don't know, maybe not.
We are
Whatever.
going to see another possibility of the prefabs. We have been using the prefabs in our example. Now we are going to see that the prefabs are going to be also very useful whenever you want to create in a dynamic way new game objects in the scene, to create and to destroy them, okay? This is going to be, for example, very common when shooting bullets, okay? So it's going to be very useful to instantiate them when you are shooting, and when they collide with something, to destroy them, okay? So in order to do that,
Wow,
we're going
he
to see that
says
the
it
prefabs are going to help
66
us
times
quite a lot.
on this page, dang.
So
In
the
this
first thing I'm
video.
going to do is to remove all the cubes we have in the scene.
Whoa!
And I'm going to move also the sphere. We're going to select the sphere. We're moving
Not
the sphere
cool,
into
bro.
one side. Okay. Well, one of the things we are going to do now is to create an empty game object. Well, I'm going to create an empty game object. I'm going to put in the middle of the scene. And the objective is that this game object is going to be a kind of volcano. Okay, so we are going to throw, let's say, a kind of stones. Well, we are going to throw the cubes. But this is more or less the idea. No? The idea is to be able to throw cubes I'm going to instantiate, and I'm going to throw them as a kind of volcano. And we are going to see that in this way, we will be forced to instantiate dynamically these cubes and to destroy them as well. So I'm going to create an empty game object. We can call volcano, for example, okay? And this game object, I'm going to put it, let's say, more or less like here, okay? A bit, almost in 1 meter in the y-axis, something like that, okay? And in position X and 0 in Z, okay?
Okay. He also spelled volcano wrong. But alright. I don't know, maybe that's how they spell it. Maybe that's how he spells it in his language, but... Alright, sure, new empty game object. Create empty. Okay, a reset. And what did he do? He does. Alright. Yep.
So this game object, this empty game object, is going to have a script. And in this script, what I'm going to do in the update is to instantiate every half second a new cube. And I'm going to throw these cubes with initial vertical force, okay? In order
Sure.
to simulate a kind of volcano, okay? Like if I were
Oh yeah, I didn't name this. Volcana! Okay. I'm trolling, bro. I'm trolling. Thank you. There you go.
launching or firing stones or something like that. So what I'm going to do is to create a new script.
Of course.
This script is going to be called impulse. Okay.
Impulse? Okay, can I rename it, bro? Rename to erupt. Now, if I go in, is it renamed already? No. Why? Why doesn't it automatically rename it? That's my real question.
And I'm going to edit this impulse script. This script is going to be part of Vulcano, okay? So as we are going to see, this is going to be a script of Vulcano. So what I'm going to do here? Well, what I'm going to do here is to, as we are going to see, to create
He repeats so much.
these game objects from the prefab. The prefab is going to be cube. So as you're going to see, the first thing we are going to add here is a game object. A game object we are going to call stone. Well, I'm going to drag and drop here in the editor, an instance of the cube. We are going to drag and drop the prefab, okay? So this stone is going to be the prefab.
Okay.
And using a specific instruction inside that date, we are going to be able to instantiate, as we are going to see, these different stones, these different cubes. Now I'm going to create another couple of variables. One is going to be a float. I'm going to call fire rate, okay? Fire rate is going to be the frequency, the rate, in which I'm going to throw a new cube, okay? In this case, half second. So now private, another variable is going to be next fire. Next fire is going to tell us in which moment I'm going to send, a new stone, as we are going to see.
Do I seriously
So
want
this is
to?
something we are going to do in the update.
Do I seriously want to? What is it? Define this right now? No.
And we are going
No,
to
I
solve
don't.
this in two different ways. In this video, we are going to throw a stone every half a second, taking into account the variable time. But in a future video, you're going to see that we are going to simplify this process using a coroutine, okay? But let's solve it just in a very traditional
Next fire. Next fire.
way using time.
I don't know.
So what we are going to do is to consult the current time in seconds. This is inside time.time. And we are going to say that if this is greater than next fire, it's time to create another stone, create another cube, and to throw it, okay? So this is what we are going to do. Inside this if, the first thing we are going to do is to calculate when we are going to throw another cube, and this is going to be in the present moment plus the fire rate, okay? So this is going to be the moment in which I will have to send again another cube. And how I'm going to create this cube? How I'm going to be able to instantiate this cube? Well, there's an instruction called instantiate.
Okay. Hold up. If time.time is greater than next fire.
And this is the instruction I'm going to use right now.
So this is just the total amount of time that's passed, right? Okay. Let me just change this to private float. Next. Okay. Let me just change it to like, I don't know, start firing. And I still don't know why this is underlined. It probably doesn't matter. Okay, cool.
Now, and in instantiate, the very first parameter is going to be stone, the prefab. So instantiate is going to create a new instance, a new game object in a dynamic way from the prefab with the properties of the prefab. In this case, it's going to be a blue
Next, fire equals time.time plus
cube with a rigid body, with collider, with all the elements, with the same material, etc. The second parameter I'm going to use
plus fire rate. I'm a little confused, but it's fine. Make field read only. Alt enter. No. Why would I do that? You know, I'll just do it his way. Because I don't really understand. And then next fire equals time.time plus fire rate. Okay.
the second parameter is going to be from which position in which position I'm going to instantiate the cube. So this script is going to be in eruption in Vulcano. This script is going to be in this game object I have created in the middle of the plane. So I'm going to use transform.position. And the third parameter I'm going to use is going to be a random rotation. Okay, so
Transform.position. Transform.position. From which position I'm going to. So is this just the position of the game object, of the empty game object? Transform.position.
I can use for that
Okay.
random rotation.
Wow, easy
So in this
enough.
way, I'm going to create a new stone. This stone is going to be created in the position of Vulcano in a random rotation, okay? And I'm going to be doing this every half second. This is more or less the idea. So I can save this script, and this script is going to be
Every half second. Okay, so why do you even need next fire? Why do you even need this? If the time is greater than? Yeah, why do you need this? Couldn't you just do like, okay. Couldn't you just do Okay, I don't know how to read time either. I mean, I guess that makes sense. I guess that makes sense. I guess it does make sense. You can't really do it any other way. Or can you? Yeah, wait. If you can do, so fire rate. Yeah. Wait, this is what you could do. You could do fire rate, okay? You could do if time.time is greater than fire rate, or you could say, if you want it to start at 0, you could just say or 0, or time.time is equal to 0, or equal, or greater than. Okay, no, equal, right? And then you could do, so time.time is greater than fire rate, or time.time equals 0. Then you do an instantiate function here. And then then after that you do fire rate plus equals fire rate. You just do, yeah. Or no, fire rate. Oh, would that work even? Fire rate plus equals fire rate. No, one. Okay, I don't know. Maybe this is the only way to do it. Fudge. Actually, can I just do this? Why do I need the 0? Stone, comma. Gosh, I really want to do this without having to go back and look at it. Yeah, I don't remember. Transform dot position. What is this? Transform dot position. Okay, what is this? Like, I want to know what this is. The world space position of the transform, but transform means you move it, right? I'm so confused. But, like, you're not moving anything. You're just declaring where it's coming from. I'm confused, but whatever. But let's just keep
And
going.
this script is going to be, this impulse script is going to be associated to Volcano. Okay, so the only thing I have to do.
Okay, cool. And then we just bang, bang. And then we see. Okay, there's nothing there. I don't know. I don't know what I'm doing. So where is the prefab? This? Okay, and then how do I do this? Oh, I could just do this. Block prefab? Where's the block prefab? Okay. Boom. Nice. Now we now we do it. Okay. Loggers. Transform dot position. Transform dot position. I'm just slightly confused. Because transform dot position. So, except it's not, and then there's a rotation. So the rotation would be like this. But then like what is telling them to point up? I that's what I don't get. It's like what is telling them to point up? Okay, I really don't understand, but
Right now is to drag and drop into Vulcano. Okay, now if we select Vulcano, we must be sure that we have this impulse script. As you can see, we have none in the stone. Well, what we have to do is to select the prefab cube and to drag and drop this cube.
I
this prefab
forgot.
cube,
I
into
forgot that you
stone.
could just go to the prefab
So,
folder.
as you can see here in the stone, we have the prefab, okay? So this means that the impulse script is going to instantiate from the prefab, okay? It's going to create new instances, but in a dynamic way, okay? In real time, in execution, okay? Now we have to do something extra. When the cube is instantiated, it's going to be very interesting that it has an initial force, in this case a vertical force. In order to do that, we are going to create a new script. It is going to be part of every blue cube we are going to instantiate. So this new prefab, we are going to link this new script to the prefab cube, okay? So this is what we are going to do. So again, we are going to scripts and we are going to create another script, C# script, we are going to call stone, okay? So
Okay. Okay, so am I tripping out? Like which axis is it rotating on? That's random rotation. So that one went straight down. You know, if I move this up further, then it should be clear. Should definitely be clear. Okay, that's too far up. Oh, okay, I see. So right now it's just dropping them. Because it's just a random cube rotation. It's not actually... It's not actually like pointing it, or it's not actually like shooting it in a direction. Alright, fair. But like still, why? So is it just the cube like rotating this way? So if I make this, and then so it's just the cube rotating on the X axis, but because it's falling, now that can't be right, right? Because that one had like a completely random rotation. So is it all three axes? Like that one? Okay. It does have to be completely random. Because otherwise, okay, yeah. I just don't understand how this is all three axes. If I do rotation, okay, just kidding, rotation. Okay, got it. That's just built in. Okay, all right. I'll accept
So
it right now,
it's going
for
to be
now.
the name, okay, of this new script. And what we are going to do in this script. So remember, this script, I'm going to link this script to the prefab cube. So the main objective of this script is going to be to apply an initial impulse force to the object. So the right place for doing that is in the start. So in the start, I can get access to the component rigid body. And directly, I can go to add force and to apply a vertical force. A vertical force, we have a constant in vector 3 that it is up, okay? And we can initialize, we can use for this, for example, impulse force, okay? Impulse force. The second parameter I'm going to use is going also to be very important. Remember, this is not going to be a constant force, it's going to be an impulse force, okay? So we are going to have an initial energy when we apply this force, okay? So the cube is going to be thrown towards the vertical axis, okay? So now we need also to initialize, to create this impulse force. This impulse force, we can initialize if you want to something such as, for example, 10, okay? That's it, okay? So this is going to be in the prefab cube. So what...
Yeah, this guy doesn't do a very good job of explaining things, but... alright. He's just like, oh, this is up? You know, this is just a thing that exists. He isn't like, why is this in angled brackets? I'm sure it doesn't make sense. It's just another, it's just another parameter thing in C#. Like some special parameter thing. And get component rigid body. So that just means that there are physics applied to it. Right? And that's it. That's all that means. Oh, it's get the rigid body of the object that you apply this to. And I forgot what this did. I don't... Okay. Whatever. Okay. I didn't mean to do that, but alright. Let's hope this actually, saved. Okay, it did. And all of these are also saved. Cool. Okay. Physics up. Okay. Wow, I really hate that. I really hate that. You can't just change the name here and then it changes it here. I hate that so much. If I do start, physics up start, and then I save it, then it doesn't, okay. Yeah, that seems like it sucks. That seems like it's gonna suck a lot in the future. Yeah, that is not what I meant to do. Okay, a get component. Can I please? Thank you. Get component. Okay, why was it? What? Okay. Whatever. Rigid body. So what does this do? Control of an object's position through physics simulation. Alright. Yeah. Rigid body. And then I have to put that too. I do dot. Sure. Add force. That simulates explosion effects. That just adds regular force. Great. And then vector 3 is just a vector in 3D space. Sure. Vector 3 dot up times, what is it? Impulse force, and then force mode. Force mode, let's just check, what does this do? Use force mode to specify how to apply a force using rigid body dot add force. Okay, so impulse, what does impulse do? That's comma, that's a comma. Okay, impulse, what does this do? Add an instant force impulse to the rigid body using its mass. Sure, good enough. I just feel like this could be done in less code if they had actually coded the, if they'd actually coded the engine differently, but... Hey, what do I know? Float. Impulse force equals, sure, let's just do exactly what he did. Why not? So this is getting, okay, so this is making it so that the object is affected by physics, or it's getting the physics. Okay, it's getting what enables physics on the object. And then this is adding a force at a certain vector. Okay, voice crack, I love it. Okay, adding force at a certain vector, but this is multiplied by whatever we want. And then this is saying that it's a burst. It's like a punch, I guess, maybe. So force mode, honestly, what other force modes are there? acceleration. Force dot force. What the what? At a continuous force. Okay, acceleration. At a continuous acceleration. So this is like velocity. This is... Okay, and then this is just an addition of velocity, not necessarily acceleration. So it's like you go from 5, and then let's say you increase it, you're at 5 meters per second. Then you tell it to increase by 3 meters per second. So then it would be 8 meters per second. So it's like instant acceleration, basically. And then this is like constant acceleration. I don't know I kind of don't know exactly what the difference is between these two. Continuous. This is continuous, this is instant. So this is instant acceleration, this is continuous acceleration. But if you have it in void start, then it's only going to do one time. So it's a little confusing, but whatever. I'll figure it out.
We are going to have right now is that when the cube is going to be created, the cube is going to execute immediately its start. And in the start is going to be applied a force, okay? So the cube is going to be initially having a force, a vertical force. Every time we create with instantiate elements, it's going to be interesting to destroy them, okay? So take into account that the more elements we have in the scene, the worse performance we are going to have. So we have to take that into account. So it's going to be convenient to destroy also, in this case, the cubes. And we are going to do it here in the update. And we are going to do it when the cubes fall down, okay? So we have the plane, we are going to start creating cubes. Many cubes are going to be present in the scene, but as you're going to see, eventually they are going to fall down. So when they fall down, I'm going to destroy them, okay? So in this way, I'm going to keep more or less a constant number of cubes alive in the scene, okay? This is the idea. And how I'm going to destroy them? Just by consulting the position in the y-axis. If this is less, for example, than
0,
for example, what I'm going to do is to destroy the object. So remember, game object, okay, in this context, if you use game object, this makes reference to the game object to which this script is attached to, okay? So we are going to destroy the game object that is the owner, okay, of this script, okay? So that's it, okay?
But this is lowercase game object. It's little g game object. Alright, sure. I'll just do that just for learning's sake. If transform dot position y is less than 1.0 f. For some reason he just, negative 1.0 f. He just really likes floats. I don't know why. I guess everything is in a float for some reason. If transform dot position. So transform dot position is taking it has all of the values for all of the axes, I'm guessing. Yeah. But then this is specifying it down to just y. Alright. I can handle that. The game object this component is attached to, okay, this one is base class for all entities. So if I did this, then it would destroy everything. Can I even do that? No, I can't because it's a class. Alright, fair enough. Fair enough, it's a class, not an object. I can't just destroy the class.
This is I'm going to save this script, stone, and the only thing we have to be sure, as we are going to see, is that we select the prefab, okay, cube. We open the prefab, okay.
Okay, I don't think -1f is gonna work though. Right? Yeah, I don't think the -1 is gonna work. Let's just see. No. No, it's not. Because it never goes... It never goes below -1. Unless I turn off... What? Okay, unless I turn off the collider, it's never gonna work, right? So if unless I turn off the collider here, then it's never gonna work, ever. So it should be going straight through, yeah. Yes, I did it. All right.
And we are going to be sure, okay, that we have this stone script attached to this prefab, okay? We can do it going, for example, here to the add component option, okay? And we are going to be able to look for scripts. And we have the stone, you see, we have the stone script, okay? So this is another way in order to assign a specific script.
Yeah, let me try that actually. Okay, so if I delete this, if I remove this, and then I do, oh. Nice, okay, got it. There's a very handy add component button right there.
Script to a specific element, okay? Now we can go back, okay? So now it's everything prepared. Let's change the camera in order to see it much better in the game view. So I'm going to select now the camera, align with view, okay? So this is the vision we are going to have in the game view. So let's see what happens. Let's run. And as you are going to see, we are instantiating these cubes, and when they fall down, as you can see, they are going to be destroyed. Okay. Okay, as you have seen, I have also removed from our script the on collision and the on trigger, okay? So now you can see the effect, okay? So the number of cubes we are going to have in the scene is going to remain more or less constant, okay? More or less, okay? This is the idea. Because as soon as the cubes fall down, okay, we are going to check the Y component and the instance of the prefab is going to be destroyed. So this is one way we have in order to instantiate objects, okay? In this way, in this case, by using the time. In a future video, we are going to see that we can make something much more convenient using a coroutine.
Using a coroutine. All right. Sure. Now this is quite a long module here.
Coroutines are a very useful.
Yeah, I think I'm just going to stop after this module, after this section here.
Useful tool in Unity. And we use them very often for different tasks. Let's see how they work. Coroutines are a very powerful tool in Unity as an alternative to threads. The main objective is to get something similar to the update method, but with your own method. So we will be able to register and stop them, and they can also finish its executions by themselves. Unity stores a list of all active coroutines that will be invoked after the late update of all the objects of the scenes. Coroutines must carry out a small action and return the control immediately. When the coroutine is invoked in the next frame, instead of starting over its execution, it will resume the execution where it let off the execution to Unity. Its implementation in C# is carried out with yield return. Coroutines will return a enumerator, and every yield return will finish the execution of the coroutine. And it
Alright, this is way over my head.
will be invoked in the next frame, continuing, and this is very important, its execution after the last yield return. So we are not going to start execution from the beginning. Coroutines are very useful in many tasks. For example, in order to carry out a sequence of actions in different moments. In order to periodically check specific conditions, for example, if we want to check out if we have finished the game level, we can do this with a coroutine and check it out every second, for example. This is better, much more efficient, than putting this condition in the update that will carry out this condition every frame, and this maybe is too often. So coroutines, again, they will be this too often.
Okay.
So coroutines, again, they will be much better understand using a little example.
Alright.
In our previous example, we were using time.time in order to launch different cubes, okay? And we were doing that inside the update method. We are going to use something different in order to implement the same behavior. But as you are going to see, the code is going to be much more clean and also is going to be much more efficient. We are going to use something in Unity we call coroutines, okay? And it's something that it is possible to use thanks that we have also C#. So we are going to go to our script impulse, and we are going to change things here. The very first thing we are going to do is to remove nextfire. It's not going to be necessary. And
Okay. Sure. We just wait until he's
You're
done
going to see
with us.
we are not going to do anything in the update either, okay? So basically what we are going to do is to use a coroutine. So a coroutine is something we have to register in Unity, and Unity what it is going to do with the coroutine is to call it every frame. So it's going to be something very similar to the update and late update. So it's going to call to the coroutine every frame. So it's going to be some kind of alternative to the update or late update. So we are going to do it in the start. We are going to use the start coroutine. And the coroutine we are going to create is going to be called throw stone, for example, okay? So this is how we register a coroutine. We say to Unity, okay, Unity, now every frame, besides the updates and the late updates, you have also to call to this coroutine called throw stone. And you have to call it till this coroutine finishes, okay? This is basically the idea. So we are going to implement this coroutine. Okay, in order to implement this coroutine, it is compulsory that this coroutine has to return enumerator, okay? And with this name, throw stone, okay, as we can see. So now it's time to implement what we want to do with throw stone, okay? Well, throw stone is going to be a coroutine, and a coroutine is very similar to any other method, but instead of using return, we are going to use something new. It is called yield return. Yield return is going to be a special return that it is going to return, okay? So the coroutine in this case is going to finish, but, and this is very important, the next time Unity calls this coroutine, instead of starting from the beginning to start over, Unity is going to continue the execution from the last yield return, okay? Keeping even the context.
The next time Unity calls this coroutine, instead of starting from the beginning, Unity is going to continue the execution from the last yield return. The next time Unity calls this coroutine,
and the value of the variables. So let's see how we can do this implementation of this coroutine. What we are going to do is to use a while, in this case a while true. So we are going to have an infinite loop here. So the coroutine is not going to finish, okay? And here inside this while true, this infinite loop, we are going to again to have the instantiate, okay? As we did, okay? So with the stone, the prefab, in the position of the transform, and again using a random rotation, okay? So the same thing we did, okay? Okay. The important point here is what I'm going to do right now. Okay, I'm going to use for the very first time this yield return. Okay, this yield return is very similar to the standard return. So this means that this method, this coroutine is going to finish. Okay, but the next time Unity calls to this coroutine, instead of starting from the beginning and to start over with the method, it's going to continue after this yield return. And C# and Unity, they are going to keep the context and the value of the variables. Okay, so this is the important difference between the return and yield return. Okay.
Oh. Okay, so it is kind of what I was saying before with fire rate plus equals fire rate. Kind of, but not really.
Because
Okay,
if we carry out a standard
you get it.
return, the next time we call to the method, we are going to start from the beginning as
But like, no. But like, I'm also completely wrong. Okay, never mind.
usual. But when we use yield return, when we return, the next time we are called, we are going to continue after this instruction. Okay? One possibility is to put null. With that, Unity is going to understand that when we make this return, the next time Unity calls to this coroutine, we are going to be called in the next frame. So null means that call me again in the next frame. And I'm going to continue from this point. So this means that I'm going to be inside the while loop all the time. Okay? So this means that I'm going to be instantiating a cube every frame. And this is something we don't want. Okay? So it's common to use this instruction we are going to do now. Instead of returning null, we are going to return an object we create called wait for seconds. Well, there are several options, but this is the much more common one. Wait for seconds.
This makes
And
more sense.
how many seconds?
For
Well, in this
sure.
case, we have the variable fire rate. Okay, so look, the idea with this instruction is the next thing. We call to the throw stone coroutine. Okay.
Okay, but my real question is why can't you do that in late update? Like, why is this better than late update?
So you
I'm looking it up. Okay. Late update versus coroutine. They never use the update anymore, instead preferring coroutines for everything, citing that it makes state management a dream, among other advantages. Firstly, could someone explain how to replace update and whether this is a good way to go? That has no advantage over update. I would say never use. I wouldn't say never use update. Coroutines are good for when you want to schedule events. For example, if you have an object moving forward, but you want it to stop for a second when you hit a key, you do something like this if you use update. The thing is, that code isn't doing the same thing every frame. Sometimes it's doing one thing, sometimes another. So let's rewrite that as a coroutine. Why can't you just have wait for seconds inside update? That's my real question. Like, why? Why isn't there a wait for seconds function inside update? Wow, if not wait, oh my gosh, bro. If not, wait. If not, ah, that is so smart. That's so smart. What the fudge? What is the difference between this and true? If true. There's nothing, right? This is 2011. Oh my goodness. Fantastic for performance. Often you don't. Functions you call every few seconds to do stuff. Oh. Oh. So it's just better. So it is literally just better. Alright. Fair enough. I don't know what I did, why I did that.
Unity with this start coroutine
Alright.
has this coroutine.
Let me stop that. Let me just, um, okay, let me just get this. And then I don't even need this. Okay, and I don't need this. Okay, got it. So update is called once per frame, and coroutine is called once every however many seconds, which does always seem better. I'm so confused as to why late update isn't built in and coroutine isn't built in, like, isn't part of this template, or I know there's an official term for like all of this stuff, like for all this stuff that they put in the file automatically. And I'm pretty sure I can pretty sure I can change this template, right? So I might just do that later. All right. Start coroutine throw stone. I'll just do um whatever. I'll just do the same thing. I don't care. Am I doing this correctly? No. Am I not? What? While true. Okay, and then yield Yield return. New? Oh, okay, but why is it new? It doesn't matter.
In the list of coroutines, it has to call every frame. So every frame is going to call to throw stone. So the first time is going to go to the while true, it's going to go inside, and in the instantiate is going to create the first cube. After that, we are going to do a yield return new wait for seconds. With that, we are saying to Unity, okay, you have to call me again, but wait fire rate seconds. In this case, half a second. After this half a second, call me again. And when you call me again, instead of starting over, we are going to continue in this exact point, okay? So after this instruction, so we are going to be inside the while loop. In order to better understand this, we can do the following. Look, we can make here a yield return, new wait for seconds, for example, 2 seconds. So now again, what is going on here? In the start, we are registering the coroutine, okay? So Unity knows that now every frame, Unity has to call to throw stone, okay? So after the update and the late update, Unity calls to the coroutines that are registered. In this case, throw stone. And the first instruction is going to execute this yield return new wait for seconds too. So this means that we are saying to Unity, okay, call me again, but wait 2 seconds. After 2 seconds, you can call me again. And when you call me again, I'm not going to start from the beginning. So waiting again 2 seconds. No, I'm going to continue from this exact point. So the second time I'm called, after 2 seconds, the next instruction is going to be the while true. And when I'm in the while true, the first thing we are going to do is to instantiate the cube. And after that, we are going to say to Unity, wait half a second. And after half a second, call me again. And when I'm called again, the next instruction is going to be this after this yield. So we are going to iterate in the loop and it's going to be the instantiate. So as you can see, the coroutines are going to be perfect whenever you have a sequence of actions you want to carry out divided by some periods of time. So if you want to do a sequence of actions and you can specify how much time do you want to wait from one action to the other, okay? As you can see, this code is much more clean than the previous one, and it is even much more efficient, okay? Because here we are waiting 2 seconds and nothing is going to be executed after 2 seconds. And here we are waiting for half a second and nothing is going to be executed until this amount of time finishes. So this is going to be much more convenient in order to implement these kind of things. Coroutines, as we are going to see in a future example, is going to be very common in many games in order to control the logic even of the game itself, okay? So the only thing we have to do now is to save and check out and see that the result is the same. The only difference is that now, when we execute, we are going to have a delay of 2 seconds. So we can go to Unity, we can run.
Sure. I'll just put that. Yield. Okay, it doesn't tell me what it does. Great. Wow. Amazing. Beautiful.
And now 2 seconds, and you see we have again the same behavior, okay? Okay, so we have seen something that it is very useful and very common in many games, the coroutines. The coroutines are special methods that instead of using return, we use yield return, the return enumerator. We have to register them using start coroutine, and after that Unity is going to call them every frame. And using yield return new wait for seconds, we will have the opportunity to specify periods of times during which we are not going to be called, okay? So as you have seen, and we are going to see in new examples, we are going to use these coroutines in order to control a sequence of
As we are going to see in previous new examples, this guy is having a difficult time.
actions that we want to happen in different periods of time.
This guy's having a difficult time speaking English. Okay, add a level of life to the sphere. Each time the sphere collides with a cube, we will subtract a unit from that level of life. And this level is 0. Okay. So, physics move. Oh. Okay, so this is... Got it. Okay, it should be right here. Um... Yeah, I'm not gonna do that. So that randomly not only the game objects created our cubes, but also capsules. Yeah. Maybe. Alright. Yeah, I'll do that. I'll do this tomorrow. Because I'm really mentally tired right now, so. Thank you guys so much for watching, and thank you for spending your most valuable resource, the time in your life, on watching my stream. And have a good one. Thank you again, XAE69, for the follow. And, yeah. Goodbye.